Right. The last thing that we're going to look at here is we are going to look at something called a Cartesian product. Right. So the Cartesian product of a set A and B, symbolized A, and it looks like a multiplication sign, but sometimes we say the word cross instead, so A cross B or something along those lines. So it looks like your normal X for multiplication sign, but we are going to use the phrase cross. So the Cartesian product is A cross B, and it's a set of all possible ordered pairs of the form A comma B, where little a is an element of set A and little b is a set of big B. In general, our cross products are not going to be equal. And then we're also going to look a little bit at our cardinality as we're going through these. So instead of just having a list of elements for these problems, we're going to have a list of ordered pairs. So we're given that set A are the letters X, Y, and Z, and set B are the numbers 1 and 2. So we're going to find these cross products. All right, so they're going to be ordered pairs. So my first ordered pair, we're going to pick something from A and match it with something from B. So I'm going to pick X, and I'm going to match it with the number 1. Right. Then I'm going to, again, you can kind of work through this however you want to. I'm going to pick X again, and this time I'm going to match it with the number 2. All right. Now I'm going to do Y and match it with 1 and 2. And then I'm going to do Z and match it with 1 and 2. And then we're going to close this off. Right? So we have the ordered pairs X comma 1, ordered pair X comma 2, ordered pair Y comma 1, ordered pair Y comma 2, ordered pair Z comma 1, ordered pair Z comma 2. If we look at this, we have 6 ordered pairs. And if we think about this, the number of ordered pairs in our cross product is going to be the number of elements in A times the number of elements in B. Well, we have 3 elements in A times 3 elements of B. So we have 3 elements in set A, 2 elements in set B, which gives us 6 total. And actually I'm not going to use an X there. I'm going to just put a little dot for our multiplication. So that way we don't get confused with the notation. And then this is not necessarily something that you have to do for every question, but as we go through it, it is kind of worth mentioning these things. All right, so B cross A. All right, so now we're going to pick an element of B. So let's pick 1. Match it with something in set A. So we're going to match it with X. Then we're going to do 1 comma Y, 1 comma Z. Then we're going to pick our other element from B, 2, 2 comma X, 2 comma Y, 2 comma Z. Right. So they look similar to our ordered pairs from our first example, but they're not exactly the same. In A cross B, we have a letter followed by a number. In our ordered pairs for B cross A, we have a number followed by a letter. Our number of elements in B cross A, again, we have 2 elements in B times 3 in A. We also have 6 elements in this set. Not only are we able to find Cartesian products of 2 different sets, we can also find Cartesian products of the same set with one another. Right? So we're going to find A cross A. So we're going to start with our first element X, match it up with itself. Then we're going to do X comma Y, X comma Z. Then we're going to do Y comma X, Y comma Y, Y comma Z. Then we still have a few left to finish off. We're going to do Z comma X, Z comma Y, Z comma Z. And if we look at this, notice that we have a larger set this time. And if we think about this, that corresponds to the number of elements that we have in set A. We have 3 elements in set A. If we cross it with itself, 3 times 3 gives us 9. All And then last but not least, we're going to do B cross B. So 1, 1, 1, 2, 2, 1, 2, 2. This guy is a lot shorter because we only have 2 elements in each. All right. And 2 times 2 gives us 4. Okay. So our Cartesian products are related to our sets, but they are different. We're not just looking at elements here. We're looking at ordered pairs of our elements of either one or more than one sets.